Hello student. The purpose of recording this video is to explain the final project for you. I have received some feedbacks from students. They asked me about this one. Okay, this is the network, about the maximum minimum of loading for the generator here. Yeah, Pmax Pmin and Qmax Qmin. Easily you can find by here. If you open any generator, you can put the maximum and minimum values by the generator by this part. So this is the part you have to put the maximum minimum of that one. Then for the transmission line also we have a maximum minimum. Where is that one? Yes, maximum real power flow. You can put this one, you can add this one too. If you double click on the transmission line, you can see limit A. So check the line and put the limitation given to that point. Okay, this is first of first. The second one is to explaining what's the meaning of, is it, yeah, for this one. Line open, what's the meaning of line open? So before of doing anything, you have to prove that your system is correctly working, which is this part. I a bit revised my rubrics. Only part one, part two, and part three is still the same, but only part one. For the part one, since I missed the in this one, if you check, okay, I forgot to put any fault location and the fault impedance. So there is no chance for me to review your result after fault. So because of that one, you only report me back as a normal condition. You can see, okay, normal, normal. Y bus normal for the power flow, not for the fault. Again, I can see in the lab one, some students don't know what's the difference between the Y bus of the fault analysis and Y bus of the power flow analysis, which totally different. Okay, and then the buses and line current during the normal condition. So this is this two. The system condition also you need to report me as a correct system. So I need to see something look like this one, a normal system, and you can find it inside this paper. I think also we have it during the normal condition. Yes, you can see the system values also given to you. And then next is, okay, let me explain this one. What's the meaning of open line? So before opening a line, you have to prove your system is correct. Okay. After that one, you prove your system. So how we should prove? I need Y bus, I need the line current, I need the bus's voltage and angle. So just a screenshot. No need to calculate manually at this point. At this point for the part one. Then you need to open a line. So opening a line based on the given line, for example, it's 1 to 2. I easily can open it such as this one. So again, make a screenshot, show me this is the open line, and then inside the bus, if you just jump in, you can see not in the buses, but in the branch, sorry, in the input. If you run for a while, I think it will work. Mm, oh, since I have no, you can see here, okay, you can see here 1 to 2 is open. It mentioned open. So this is one of the way you can prove that your system here also, you can see it's open. So after this one, you can show me that your system Y bus also change. So the Y bus after and before is can be considered such that one. So no need any fault condition. So this is the meaning of the opening a switch. Then what's the meaning of line 3, 5, 6 as an example? Go back to this one, 3, 5, 6, I think. Let me, okay. Right now you have to find out the 3, 1, 2, 3. Okay, this is 3, then 5, and then is 6. So this is the line from here, then here, going back, and reach to this point. So how many relay I have to set? This is the one relay. This is the first one relay you are going to set. So maybe on behalf of having the full load, you can find the current of the loading at this point at the end, just end of transmission line. You know how to calculate that one. Then, so this is one relay. You can find it. This is the relay one. This is no need to consider. This is the next relay you have to consider, and then this one no need, and this is the last relay. So how many relay for overcurrent you have to consider? Only three, correct? Okay. Then for the other way, which is the okay, the this part of the project here, you only need to show me the characteristic. So easily you can copy and paste the same as here. Okay, this is moderately inverse, and what is the value? So show me the value and the equation, how the equation change. The equation is given here also to you. It's very simple. Okay. And then the dt discrimination time is given to you. Finally is the distance relay. For the distance relay, for example, these students has it from 1 to 2. So go back to this one, where is the system 1 to 2. So unfortunately, I have to turn it on. So assume it is, I open another line, assume, okay? Assume this one, okay? 1 to 2 is this relay. So from 1 going to 2. So this is the relay, distance relay. I choose this one. This is the distance relay I choose. And then the first line, 80, 90% is very clear. Just after that one, you have many choice. Okay, maybe this one, maybe this one, maybe this one, maybe this one. If it's off, so no need to consider, it's off. Okay, correct. But if it's on, you must consider that one on the same way. So after that, zone 2, you have to consider the in-feed current, and for the zone 2 and zone 3. So based on the regulatory, you can choose, assume this is the zone 2, and then zone 3 may be coming again by another way, maybe coming by this one. So you have to consider the in-feed current for the zone 3 also. For the lab 2, our challenge was overcurrent relay, since we have 4 overcurrent relay and transformer. But for the final exam, for final project, it's come to the distance relay, since we have a different in-feed. So you have to consider the different scenarios, find out the worst of worst. The worst of worst is that one with the biggest K. So that one no need to be considered. The smallest K must be chosen. This is the hint to help you. And then let me know if you have any question regarding this project. Thank you very much. Good luck, guys.